Hi Pre-Calc students, time for another online lesson as we move into chapter 3 here. Today on symmetry and coordinate graphs. I think you'll recognize some of these ideas, and this will be largely a visual lesson, so I think you'll do pretty well in it. Most of you have an idea what we mean by symmetry, and interestingly enough you can try to figure out the symmetry of the word symmetry here, the way it's written. But basically symmetry we think of meaning the same on both sides, or if you fold something over itself, it will land on top of itself. So as you can see with this flag and the letters, the butterfly, we have various types of symmetry that we're going to learn about in this lesson. The thing we're going to take a look at is symmetry with respect to the origin, and we'll be examining whether various graphs are symmetric with the origin. If we have the point AB, let's say that's on the original graph, and if this graph is symmetric with the origin, then this point, negative A, negative B, is also on the graph. And then here's another fancy definition there too. The f of x, that's the y value, would have to be the same as the y value for the opposite of x. Those are a couple of tests to see if something is symmetric with respect to the origin. But by far we will mostly use this visual test, and that's to rotate the image 180 degrees, and it should look what? Actually the same or identical. And so if we do that, and it's a pretty easy task with your calculator, indeed that will be the primary test that we use to see if we have symmetry with respect to the origin. Now here's a pretty famous function here. This is y equals x to the third power. Is this symmetric with the origin? Well, you could graph this on your calculator. It would look something like this. And again, if you rotate this 180 degrees, so turn your calculator 180 degrees, does this look the same? And yeah, certainly it does. We could also test these other points as well. For instance, we note that if it's y equals x cubed, the point 2 and 8 would be on the graph. And then according to our definition here, if 2, 8 is on the graph, then negative 2, negative 8 would be on the graph. And sure enough, we would see that it is. Okay? And then we could also use this other test as well. But by far, this is our main test, more of a visual test for this kind of symmetry. Now we get into line symmetry, and with line symmetry, again, most of the time we will use sort of a visual test, because again, with line symmetry, the graph will fold onto itself when you fold it over these particular lines here. So, for instance, a good example here, this is a chart that's probably good to copy down because it does have the various kinds of line symmetry we're going to look at. The algebraic definition, these are good to know and we'll verify it. And then just a quick example of a graph that might have this type of symmetry. So, first of all, x-axis, that of course is pretty self-explanatory. Here's the algebraic definition. Again, all these are if AB is on the graph, and then we see these various variations algebraically. Here's a good example of that. If I had kind of a sideways parabola that looks something like that, clearly this would be symmetric over the x-axis. Folded over the x-axis, it would fold onto itself. Now, the one trouble with this is that this is not a what? Function. So we won't see too many of these, but keep in mind that it is a good representation of symmetry with the x-axis. Now, what about the y-axis? Well, obviously pretty similar there too. You fold the function over the y-axis, and sure enough, it will be symmetric. So here's an example of that. Again, more of our traditional parabola, which might look something like this. The line y equals x. This one's a little bit trickier perhaps. You can see the algebraic test there, which you could substitute in on, and we will try that sometimes. Here's maybe an example of being symmetric with the line y equals x. Here we have kind of a parabola, or excuse me, a hyperbola type thing. The line y equals x, by the way, is that line that goes diagonally through the origin like that. And I think you can kind of visualize that if we folded this graph over it, it would fold onto itself. And same thing with y equals negative x. This would be a similar type of figure, perhaps. Maybe I could have well, I'll even use that very same hyperbola type thing. The line y equals negative x, of course, is a slanty line as well, but it comes in from that other direction like this. So there's some examples of some line symmetry in the algebraic tests you could use, but primarily we'll be using more of a visual test. So here's a couple of examples here. Determine the symmetries of this particular function y equals negative absolute value of x plus 3. You can try that on your graphing calculator. It should look like this with a standard window. Now, what kind of symmetries would you say this has? Well, first of all, we like to see if it's symmetric with the origin. Well, turn this 180, that's not going to work. It'll look the same, but the actual absolute value arrow will be pointed in reverse direction. What about the line symmetries? Well, again, it has to fold onto itself. It doesn't look like the x-axis would work, nor this line y equals x or y equals negative x. But the one thing that is symmetric, it looks like, is the y-axis. So this is clearly one where we'd say this one is symmetric with the y-axis. Again, on your assignments, when you have something like this, I do want you to sketch the graphs, and then from looking at the graph, you should be able to clearly see what that symmetry is. A bit trickier. Y squared equals 4x squared minus 16. Now, your first inclination, and it would be a good one, is, well, if I solve this for y, then I could graph it, and then I could tell what the symmetry is. So it sure looks like I could probably take the square root of everything, right? Square root of y squared is that. And the square root of 4x squared, it would appear to be, is 2x minus 4. Simply take the square root of each of those. This looks like it would just be a nice linear function. We have a y-intercept at negative 4 and a slope of 2. So fairly steep sloping line like that. Looks like that's what the graph would be. What kind of symmetry does this have? Well, if it's a straight line, depending where it is, it might have some symmetry, but this one really doesn't have any. Except the only bad thing is that we don't want to do this. This is not the square root of 4x squared minus 16. And the reason it isn't is because if you squared 2x minus 4, you would not get that to be equal to 4x squared minus 16. Remember our FOIL method when we square binomials. So we have to have another way of visual approach is going to be best. Notice on your calculator here, you can actually enter that. I can take the square root of these, but then don't try to do anything more with it. Just write it as the square root of 4x squared minus 16. Notice you do have to have parentheses around that on your calculator. But here's the other key thing that you may not have realized. Not only do I need to take the square root of that, but I need to take the negative square root of it. And both of those are vital on a problem like this. And if you think about it, it's a little bit like taking, well, what's the square root of 16? Well, it could be 4 or it could be negative 4. That's kind of our thinking here. So really you need two different graphs entered into your calculator in order to graph this correctly. And here's the result. Again, this is another one of these hyperbola type things. What would you say about the symmetries here? Well, is this going to be symmetric with the origin? If I rotate this 180, is it going to look the same? I think in this case we can say yes, that it will. And so the origin is going to be 1. What about any of our y equals lines? Well, it certainly looks like the y-axis would work, doesn't it? Clearly, if you folded it over the y-axis, it would fold onto itself. And I think even in this case, we could say that the x-axis would be a line of symmetry. I don't think that either the line y equals x or y equals negative x would work in this case, but clearly we have about 3 good lines there that we can take a look at for symmetry. One of our options on our assignment card, as you'll see is, and you've seen these around the room too, is can you write your name using some type of symmetry? And here's some examples. I'm going to give you a sheet with these on as well, but this is kind of interesting to look at to see if you could write your name with some kind of symmetry. These things are called inversions, and this is going to be an option for you on the right side of your assignment card as well. All right, thanks for watching today, and we'll see you guys in class.